All right, let's try something a little different today. We're not just going to talk about how Bitcoin was invented. No, we're going to try to invent it ourselves, right here, right now. Forget a lecture. Think of this as us together in a workshop. We're going to face the same tough questions, the same dead ends, and see if we can piece together the same brilliant solutions.
Okay, so right out of the gate, we hit a massive wall. The beautiful thing about the digital world is that you can copy anything. A photo, a song, a document, 1,000,000 times, perfectly, for free. It's amazing, but for money, that's a total disaster. Money has to be one of a kind. So how in the world do you solve that? How do you make something that's just bits and bytes, completely unique?
And that question right there, that's the heart of it. It's the one puzzle that stumped some of the smartest people for decades. It even has a name, the double spending problem. If we can't crack this one nut, none of this is going to work.
Think about it like this. In the real world, it's simple. If I hand you a coin, my hand is empty. It's gone. The transfer is final. But if I have a file called My Digital Coin and I email it to you, well, I still have the original, don't I? I could send that same file to 100 other people. We've just created money out of thin air, and our whole system collapses.
So what's the old school solution? Well, we basically just hire a referee. We use a trusted middleman, like a bank or Visa or PayPal. They keep the one true list of who has what. When I pay you, they mark down my balance and mark up yours. Simple. But that means we have to trust them, right? And it also means there's this one central place that can be attacked or controlled or just plain shut down. Our goal here is to build something without that.
So, what's our first big idea? Let's get creative. What if, instead of one central ledger locked away in a bank vault, we all have a copy of the ledger? A shared, public notebook that everyone in the world can see. No more middlemen. Let's see where that gets us.
Okay, so with this shared notebook, transactions could work like a chain of custody. It's not about balances in an account. It's more like the book shows Mike got 10 shiny new coins. Then a new entry shows Mike gave those same coins to Alice. Then Alice gives 3 of them to Bob, and the book shows she gets 7 back as change. To spend money, you just point to the entry where you received it. It's actually a pretty elegant way of doing things.
But wait a second. You've probably seen the hole in this already, right? We just created a huge problem. If this ledger is public, and anyone can write in it, what's to stop me from just scribbling in a new line that says Alice pays me all of her coins? We need a way to prove that only the real owner of the coins can actually spend them. We need a signature. And that leads us to our next big breakthrough. We need a signature, but for the digital world. And it can't just be any signature. It has to be one that is mathematically 100% impossible to fake. Something only I can create, but that everyone else can easily check is legit.
Luckily for us, the perfect tool for this already exists. It's this beautiful, kind of mind-bending idea called public key cryptography. Here's how it works. Everyone gets a pair of digital keys that are mathematically tied together. They have this amazing property. What one key locks, only the other key in the pair can unlock. It's like magic, and it's exactly what we need. So with this system, you have 2 keys. First, there's your private key. This is your secret. Think of it as the pen you use to sign a check. You never, ever let anyone else touch it. Guard it with your life. Then you have your public key. You can shout this from the rooftops. It's your address, how people can pay you. And it's also how they can check that a signature made with your private key is authentic, without ever knowing your secret. It's incredible.
Awesome, we did it! Forgery is now impossible. No one can spend my money unless they have my secret private key. It feels like we've built a perfect system. We can all go home, right? Well, not quite, because in solving one problem, we've stumbled face first into another one. And this one is way more subtle.
The problem is all about order. See, in our decentralized system that's spread all over the world, there's no official clock. There's no single source of truth for what time it is. If 2 people announce something at the same time in different parts of the world, who's to say which one came first? And that opens up a huge vulnerability. So just walk through this with me. Let's say I've only got 1 coin left in my digital wallet. I create a transaction to send that 1 final coin to you. I sign it with my private key. It's 100% valid. But at the very same instant, I create a second transaction. And it's also perfectly signed and perfectly valid. And in this one, I send that exact same coin to somebody else. Then I just blast both of these transactions out to the network at the same time. So here's the mess we're in. Both transactions look legit. They're both signed correctly. Some computers on our network will hear about the payment to you first,
Others will hear about the payment to person B first. Who's right? How does the network all agree on a single version of history? Without that agreement, we don't have a currency, we just have chaos.
And this is where the real stroke of genius comes in. The solution is to totally change how we think about the problem. We have to stop relying on trust. We have to stop worrying about who heard what first. We need to invent a way to make it incredibly difficult and expensive to add a new page of transactions to our ledger. We need a system where people create order by proving they did real, costly work.
That system is called proof of work. You can think of it like a giant global lottery. In order to earn the right to add the next page or block of transactions to our public ledger, you have to solve an unbelievably difficult math puzzle. It takes a ton of computing power and electricity to find the winning lottery ticket. But, and this is the beautiful part, once you found it, it's super easy for everyone else to look at it and instantly verify that, yep, you're the winner.
So somebody finally wins the lottery. They solve the puzzle and they get to add their block of transactions to our ledger. But here is the final, brilliant lock on the system. Each new block must contain a digital fingerprint of the block that came right before it. This links them all together, one after the other, in a secure, time-stamped chain, the blockchain. To go back and change something in an old block, you'd have to resolve the puzzle for that block and every single block that came after it, faster than the entire rest of the world combined. It's basically impossible.
Okay, this is amazing. We've built an incredible, secure, decentralized system, but we have one last, very practical question to answer. This puzzle-solving lottery, it costs real money. It burns a ton of electricity. Why on earth would anyone even bother to do it?
And the answer is just so clever because it harnesses pure self-interest to make the network secure. When one of these miners solves the puzzle and adds a block, they get a reward, actually 2 rewards. First, they get to include a special transaction that creates brand new coins out of thin air and pays those coins to themselves. Second, they get to collect all the tiny transaction fees from the people whose payments they included in their block. All of a sudden, there's a massive financial reason to play by the rules and help secure the network.
And that reward system, that creation of new coins, it also defines the money itself. The block reward is programmed from the very beginning to get cut in half every few years. This means there's a hard mathematical limit on how many coins will ever exist, 21 million. And that's it. For the very first time, we've created true, provable digital scarcity. And there we have it, we did it. By tackling one problem at a time, the copying problem, the forgery problem, the ordering problem, and the incentive problem, we have, from scratch, built a peer-to-peer electronic cash system. We've completely replaced the need for trusted banks and institutions with cold, hard, cryptographic proof and computational work. So the real question isn't just how does it work anymore? Now that it exists, what does a system built on proof instead of trust truly make possible?